All right, hello everybody. This is Ms. Piekarski. I am giving you the rest of the note information for your blue notes. We are looking at your tangent and cotangent graphs. I know in class today we had this information. Make sure you have all these extra formulas written down for your x values. You need to know how to find the x value for your left anchor and your right anchor. These are the formulas. And you need to know how to find your b value. So if your period is equal to pi over b, then if you know your period and you want to find your b value, then it would just be pi divided by your period. Okay. The reason why we're using pi instead of 2 pi is because the standard length of one cycle for tangent and cotangent is pi. So get these notes down. Notice that even though our cotangent function is shifted, these formulas still work. For your y values, these points are still the same formulas for your y values. And then for your x values, you have this point for your this formula for your asymptote, this for your center point, and then this for this asymptote, and oops, sorry, no, slightly different. Let me go ahead and erase that and I'll fix it. Sorry, so this is going to be for this asymptote here, and then your formulas will be slightly different. They'll be the same kind of formulas for sine and cosine. This one, it would be your c value plus pi over 4. So basically this formula, but with a plus sign instead of a minus sign. Or, well, I guess there's pi over 4, isn't it? And then this one would be c value plus half a pi. This one would be c value plus 3/4 of a, not pi, sorry, 3/4 of your period. And then this last asymptote would be c plus 2, no, c plus your period. So c plus your period for this one. And then for this one, c plus half of a period, so whatever your period length is divided by 2. This one would have your period divided by 4, and this one would be 3/4 of your period length. Okay, I'm going to go through the rest of these very quickly. In class, I showed you how to find your left asymptote, your anchor. Your anchor points are these ones, the origin, and then the ones that are at 1 and -1. So normally these are at pi over 4 and 1. So those are your normal anchor points, and your inflection point, the center, where you're flipping back and forth. You can fill these are for your blue notes. Go ahead and fill them out. I've graphed everything. I'm showing you what the transformation is. Pause this, fill this out, and then push play again. Hopefully that makes a lot of sense to you. You need to know how the A and the B values stretch and compress. This one you're stretching. Notice your B value is a fraction, and you're stretching. And then here you're shifting to the right, pi over 2 units. With this one, you're just reflecting over the x-axis. I know I'm going through this very fast. Go ahead and pause it if you need to. Let me back this one up. I was not here very long. Go ahead and pause this, write this down, fill out your notes. Then we already had this one. This one, when you have a negative A value where you're reflecting and you're moving it over half a cycle, then you actually have your cotangent function. Okay. Now with this one, with our secant and cosecant, again, we saw these formulas in class today. I went ahead and showed you your secant graph. With this one, this would be your x equals c value, your asymptote here. This one would be c plus pi over 4, and then this one would be your next asymptote. And then this one, 3 pi over 4 plus c. And then the last one would be c plus pi, period. Okay? Yeah, that's for the asymptote here, this asymptote. All right, so you have all these formulas. Let me move it out of the way. whoops, I erased the B value. Okay, you should have gotten all this in class. Just in case you forgot to write it down, here it is. And I think in class I did not compare the secant and cosecant graphs. So there you have it. Oops. And then again, we're going to go through some of your transformations in your notes. In class, we talked about the minimum and maximum. Make sure you remember this is a minimum because relative to this section here, this is the lowest point. This is a maximum. Sorry, it's really loud in the halls right now. I don't know why. There shouldn't be anybody there. So there's some background noise. This is your maximum. That's your relative maximum there. We went through that in class. Make sure you know that those are, even though minimum is above the maximum, this is relative to this section. This is a maximum point relative to this section here. And then go ahead and pause this and jot down these notes. If you have combined absolute value functions of secant, and everything's up top. It looks kind of like curtains. It's pretty cool. With this one, you're stretching by a factor of 3. Pause it so you can write everything down. With this one, you're shifting to the right by pi over 2, which ends up changing the location of all your asymptotes. And then you have, this is also the same as your cosecant graph. And that's it. All right. So hopefully you have all your notes down and you are ready to go. Let me pause this.